Wireless chargers are an important innovation in consumer electronic and smart devices, which offer a convenient and cable-free method of charging electronic devices that are widely used to charge smartphones, smartwatch, wireless earbud, and other compatible devices through electromagnetic induction that eliminates the need for physical charging connectors. Unlike conventional chargers, wireless chargers transfer electrical energy using a changing magnetic field generated between a transmitter coil in the charging pad and a receiver coil inside the device. This technology demonstrates the practical application of electricity and magnetism in modern consumer electronics while improving user convenience. The increasing adoption of wireless charging highlight the growing importance of electromagnetic principle in advancing smart technologies and improving user daily life. These are some of the significance of wireless charger in our life. Firstly, it demonstrates a practical application of electricity and magnetism. Wireless chargers are one of the best examples to show that the principle of electricity and magnetism are not only theoretical concepts, but also applied in modern technology to transfer electrical energy safely and efficiently without using cables. Wireless charging has contributed significantly to the advancement of consumer electronics by enabling manufacturers to design devices that are more compact, durable, and user-friendly. Since charging no longer depends solely on physical connectors, devices can have fewer external openings, improving the resistance to dust and water. Also reduce mechanical wear on charging parts. Other than that, it also can support smart homes and infrastructure. Wireless charging technology plays an important role in the growth of smart home and infrastructure. It increasingly integrated into furniture, office desks, and other public spaces, allowing users to charge their devices conveniently without carrying cables. In smart homes, wireless chargers can work together with other IoT devices to create more seamless and connected environment. Lastly, wireless charger can encourage standardization and future innovation. Most wireless chargers use the PHY wireless charging standard, allowing compatible devices from different manufacturers to use the same charging technology. Wireless charging continues to evolve toward faster charging speeds and greater convenience, supporting the development of more smart furniture, electric vehicles, and fully wireless consumer electronics.
Now let's discuss the electricity and magnetism concept involved in wireless charging. Wireless charging is based on two important principles of electromagnetism, which is Ampere's law and Faraday's law. The charging process begins in the charging pad, which contains a transmitter coil. Wireless chargers work by using electromagnetic fields to transfer energy. According to Ampere's law, when an electric current passes through a coil, a magnetic field is generated around it, causing the coil to act as an electromagnet. The strength of the magnetic field depends on the amount of current flowing through the coil. Therefore, a stronger current produces a stronger magnetic field. The charging pad contains a component called the transmitter coil. When the charger is connected to a power source, electric current flows through the coil, generating a magnetic field and turning it into an electromagnet. Wireless chargers use alternating current or AC, which continuously changes direction. As the current reverses, the magnetic poles of the electromagnet switch back and forth rapidly. This creates a constantly changing magnetic field, which is necessary for electromagnetic induction and enables wireless energy transfer to the device. Next, let's look at Faraday's law. According to Faraday's law, a changing magnetic field can generate an electrical voltage known as electromotive force or EMF in a nearby conductor. This induced voltage causes an electric current to flow, allowing energy to be transferred without direct physical contact. In wireless charging, the changing magnetic field produced by the transmitter coil induces a voltage in the receiver coil of the device. The device being charged contains a receiver coil that captures the changing magnetic field produced by the transmitter coil. This changing magnetic field induces an electromotive force or EMF, generating an electric current that transfers energy wirelessly to the device. The received electrical energy is initially in the form of alternating current or AC. However, electronic devices such as smartphones and smartwatches require direct current or DC to charge their battery. Therefore, a component called a rectifier converts the AC into DC by allowing the current to flow in only one direction. The converted DC power is then used to charge the battery safely and efficiently. In summary, wireless charging works through the combined principles of Ampere's law and Faraday's law. These principles allow electrical energy to be transferred wirelessly from the charging pad to the device and ultimately charge the battery.
Next, I'm going to explain some of the real examples of the application of wireless charging. The first one is wireless charging vehicles parking. Wireless charging technology is increasingly being used not only inside vehicles for charging smartphones, but also in dedicated parking spaces for charging electric vehicles, EV, for example like BMW iX. In this system, a charging pad is installed on the parking surface while a receiver coil is fitted underneath the vehicle. When the vehicle is parked in the correct position, electrical energy is transferred wirelessly from the ground pad to the vehicle's battery through electromagnetic induction. The second one is wireless charging for wearable devices. Wireless chargers are widely used to charge portable smart devices, including our smartphone, smartwatch, and wireless earbuds. Instead of connecting to a charging cable, users can simply place the compatible device on a Qi-certified wireless charging pad like Apple MagSafe. The charger generates a changing magnetic field that includes electric current and the receiver coil inside the device, recharging its battery through electromagnetic induction. Lastly, public wireless charging station. Nowadays, we can find a lot of wireless charging stations are being installed in the airport, shopping malls, and other public spaces to provide convenience charging for compatible smartphone and other technology devices. These stations typically feature built-in Qi wireless charging pads integrated into table, countertops, kiosks, or sitting areas. Users simply place their compatible device on the designated charging surface and electrical energy is transferred wirelessly through electromagnetic induction without the need for personal charging cables.
There are a few potential benefits of wireless charging. First, increased convenience. Wireless charging is very convenient because users only need to place their device on a charging pad instead of plugging a cable. This makes charging easier and faster in everyday use. Second, improved durability. Since there is no need to plug and unplug charging cables repeatedly, the charging port experiences less wear and tear. This helps extend the lifespan of electronic devices. Next, enhanced safety. Wireless charging reduces the risk of electric shock and short circuit because there are no exposed charging connectors. Many wireless chargers also include safety features such as temperature control and overcharge protection. So now let's look at the potential challenges of wireless charging. First, lower efficiency. Wireless charging is generally less efficient in tropical climate countries such as Malaysia because some energy is lost as heat during the charging process. Next, limited charging distance. Wireless charging requires the device to be placed correctly on the charging pad. Even a small misalignment can interrupt or slow down the charging process. Lastly, wireless charger may have higher cost than traditional chargers because wireless chargers need to be bought with compatible devices which are often more expensive than wired alternative. Plus, not all devices support the same wireless charging standard, which may require different chargers.
Wireless charging is a technology that transmits powers without using any cable, thereby eliminating clutters and preventing damaged charging ports. To maximize this potential, development and innovation is vital. This involves creating products that benefit both society and the planet alike. Although wireless charging has improved greatly, it has several drawbacks. First, it is slower than wired charging for most devices. Secondly, it generates more heat, which can reduce charging efficiency and potentially affect long-term battery health. It also requires proper alignment between the charger and the device. Some energy is also lost during the transfer. First innovation might be faster wireless charging. Creating a new coil design with a better cooling system and improved power management could allow wireless charging to approach wired charging speed while generating less heat. Secondly, longer distance charging. Instead of placing a phone directly on a charging pad, future system may allow devices to charge from centimeters or even a few meters away by using radio frequency, magnetic resonance, and infrared technologies. Another exciting future development is the ability to charge multiple devices simultaneously using just one wireless charging station. Instead of using a separate charger for your phone, smartwatch, and wireless earbud, you can place all of them together on a single charging pad. This technology definitely can save more spaces and reduce cable clutter and makes charging more convenient. Universal charging means using one common charging standard for many different devices. It can definitely reduce the needs for multiple chargers and cables. The best example today is USB-C, which is increasingly needs for smartwatches, smartphone, laptops, and so on. The benefit of making it as a universal charger is that we can reduce electronic waste, lowering the manufacturing cost, and it could be a greater convenience for users.
In conclusion, wireless charging have become an important innovation in modern smart devices, offering user greater convenience, reduced cable clutter, and improved durability by minimizing wear on charging ports. From the perspective of consumer physics, wireless charging demonstrates the practical application of electromagnetic induction where energy is transferred efficiently through magnetic field without direct electric contacts. Although wireless charging is generally less energy efficient and slower than wired charging, ongoing advancement in charging technology continue to improve its performance. As demand for convenient and sustainable consumer electronic grows, wireless charging is expected to play an increasingly significant role in everyday life, Overall, the study of wireless charging highlight how fundamental physics principle can be applied to develop innovation technologies while driving progressive consumer electronic industry.